Professor Hoffman asked me to step in today to talk about the space shuttle and the military. I'm going to do that. I encourage questions. I may not be able to answer all your questions, either because A, I don't know, or B, I can't say. And I'll leave it to you to figure it out which one is which. So I would like to say a few things before I start. One is, I'm not a historian, so I'm not here to give the history of the military and the shuttle. I'm here to give you my experiences with it, which is a very select data slice, I think, as you will see. Second, the things I say here, although we're going to tape them, I have to couch very carefully. And third, I speak from a different era. I speak from an era of the 70s and early 80s, when the political situation was a lot different than it is today, when the Cold War was hot, when there was a real threat of a massive land war, plus worse, in Northern Europe, when there's real threats of nuclear exchanges between the superpowers, things which are not true today, thank goodness. We have now been overcome by other threats and challenges. But I speak really from an era of the 70s and 80s. So with that, I'd like to start. Again, I encourage questions. Here's what I'd like to do today. I'd like to give you a little bit of intro and background, talk about DoD and Air Force space missions. There is a difference, which I shall highlight. I'll talk about military system requirements and impacts on the space shuttle as a system. I'll talk about facility impacts because that's easy to do, but there is impacts that are far more far-reaching than that. I'll close with a little bit on national space policy, then I'll show you a 10-minute video. And for that video, I'd like Tom to turn off the recording, and we'll just watch it kind of in silence. Okay, any questions? My background is I served 29 years in the Air Force. As you folks know, you can retire after 20, so I couldn't count. I stayed far longer than I should have. The reason I stayed was because the Air Force gave me assignments I couldn't turn down. I've had launch experience from a program office payload user's perspective on Shuttle, Titans off both coasts, MX, Pegasus XL. In January, last January, I gave a talk, which I'll repeat this year, on my activities on 2 accident investigations, one on Titan 4 and one on Pegasus. I do that at one time. It takes about an hour and a half. If any of you are on campus in January, please come by. It's an interesting story. I served in multiple program offices in programs A and B. Programs A and B are subsets of the NRO. I won't say any more about that, but Program A is the Air Force element. Program A not only built Air Force satellites for the intelligence community, they also provided all the launch services for the intelligence community. I've been the SPO director of 2 major programs. The first one was Space-Based Infrared Low. The second one was the DoD Space Test Program. I've also been the NRO director of safety. In general, Air Force and DoD space missions fall into this laundry list. The first one is navigation, which you, of course, know from GPS. Communications, which has many satellites, of which Milstar and Discus are probably the ones you recognize. Discus was launched on the space shuttle, I believe twice, not sure. Meteorology, the Air Force launches the DMSP, which is a polar orbiting weather satellite, replaced by the NPOS system. For missile launch detection, the intelligence community and the Air Force have either operated the DSP satellite system or else proposed as the SBIRS, which is suffering tremendous programmatic problems currently. For arms treaty verification, it's terribly important to have complied at one time with SALT and START limitations. That's an interesting slice of history where at one time the total number of warheads, total number of bombers, submarines, ships, this sort of thing, was limited by international agreement, but it was the responsibility of the other side to verify compliance. There's also nuclear weapons test detection on Vela, and then a whole handful of what I call intelligence community or IC programs. Bob Siemens, a retired professor emeritus, is planning to drop by today for the Q&A. His position, his role in this story is really very central. His influence is woven throughout the whole story of the DoD and the space shuttle, and I hope you will get a chance to talk to him. Extremely interesting and very pivotal guy. I'd like to concentrate on Vandenberg Air Force Base rather than the Eastern Range for the space shuttle, because the Vandenberg Air Force Base launch site was really built up for sun-synchronous polar orbits for really one payload. And that was the fellow here depicted in late 1970s, launching out of the Western Range. This is a Titan 3D. I've helped launch, I think, 8 of these off the West Coast. This is a heavy lift machine. Puts roughly 30,000 pounds in the low Earth orbit, 27 or 30. Has 2 solid strap-ons. I saw the first one go in 1970, and subsequently was able to transition into the program office to launch several times out of there. As some of you are aware, because I've talked to you out of class, I served for many years not in what we call the regular Air Force, but in what's called the Office of Special Projects. It's called an Air Force element. We did not report to the usual chain of command through the Air Force chains. We went straight up to the SecDef and the JCS. We were given the responsibility to launch things quickly, quietly, with great national pressure, and we did that. And the machines we used to launch our payloads included Titans of various kinds, Atlases, as well as a space shuttle. So the story I'm going to tell you is really the special projects utilization of the shuttle, more so than what I call the regular Air Force missions. In any case, when I joined SAF-SP in the late 1970s, life was really exciting. We were in the midst of phasing out all the expendables for the space shuttle. And when I went in there, I found within the first week they said, the space shuttle is designed for our program, because we were flying on a regular basis out of the Western Range. So the payload that sits inside here is a form, fit, and function drop-in into the space shuttle bay. At the time, there were no space shuttle payloads of that size yet on the drawing boards. The intent was to have a seamless transition from Titans into space shuttle, first for our program and then for others. So we drove the payload bay size, as you've heard from Professor Hoffman and Aaron Cohen, 15 by 60. The cross-range requirement dictated the configuration of the vehicle plus the wing size, because the Air Force and the DoD was very, very insistent on having a return-to-launch base capability. First orbit deploy, come back cross-range, land back at Vandenberg, recycle, be ready to go, hopefully in a matter of days. It's interesting to note the evolution of the Titan space launch family. In the 1970s, we pick it up with the Titan 3D. We see here. The 3E was a trans-age version used for basically outer space missions. This is a commercial version. But the DoD use went from the 34B, 3C, 34D, through this family here. And now we see the 4A and the 4B, which are the heavy lift guys. These guys basically were the follow-on to Shuttle. They lifted the shuttle payloads that the shuttle could not carry, and we'll explain that in a few minutes. Very large, expensive, complex machines, complex programs. At Vandenberg, it turns out that back in the 60s, there was a program called the Manned Orbiting Laboratory, MOL. Many of the original space shuttle Mercury astronauts were part of that. They built up a space launch complex up there called Slick 6 to launch the MOL. It was going to be a space capsule with military officers on board to do reconnaissance and surveillance, flying off a rather large Titan 3C. To do that, again back in the 60s, they built a launch pad. And then as we got ready for the shuttle, they took the MOL things and did all these things to it to make it shuttleized. They upgraded the launch pad. They put in a mobile service tower. As you know, at the Cape, what they do is they kind of embrace the shuttle in its stack with a gantry, and they pull back a little bit, and then they launch. The mobile service tower is a large, almost like a skyscraper complex that completely encloses the rocket during processing, and then rolls back several hundred yards to expose the vehicle for launch. A totally different ops concept. This facility here, the OMCF, is similar to the KSC orbiter processing facility. Then we have other facilities here, the payload preparation room, where the payloads are received from transportation, put together and tested. The PCRs, where the payload is actually put into the shuttle bay. The Vandenberg runway was almost doubled in length, and then all this infrastructure is put in here, including crew quarters for the astronauts, and they were able to reuse the MOL facilities. A lot of secure comm, but what you see here is the buildup of a complex very similar to Cape Kennedy, only on the California coast. Very, very elaborate, very, very complicated, very expensive, and taking a tremendous amount of budget to go do it. Back in the 70s, by law or by policy, which is perhaps even more powerful, the Space Shuttle was going to be the only launch system for all military, civil, and commercial payloads. This is somewhat of a forgotten fact, but at one time, the cry went out from the advocates that said, by having a reusable spacecraft that can launch 25, 30 times a year from both coasts, so that's times 2, we can do great things. And certainly, coming from the folks who gave us Apollo, this did not seem that far-fetched. The idea of launching a spacecraft like an airliner, as we know, did not happen in our generation. I think in your generation, if you can make that happen, that would be extremely wonderful. But at one time, there was going to be a phase-out, a shutdown of all the launch vehicles. All the launch vehicle folks were told, fly out what you have, close up business, break up your tools and dies, send your people home. We are going to go shuttle. And to do that, there was extensive redesign of payloads to fit the payload bay, the width, the length, to fit the safety requirements. All these things changed, so it was not just a matter of just taking your existing payloads for these guys and dropping them into the shuttle payload bay. It was a huge engineering effort, and we thought at one time this is going to be the way it's going to be forever. The things that are unique about this is, first of all, the liftoff and flight loads are much different because of not only the main events, from everything from the SRBs to staging, but also being able to survive safely. Things like slap down on landing if you had to come back home with a payload. Many of the heavy payloads require, as you know, upper stages. The PAMs are the small payload assist module, small FICOL kick upper stages. The IUSs, as you probably heard, are much, much more elaborate solid fuel devices. The Shuttle Centaur, Cryo Centaur, was going to be a cryogenic upper stage that was going to take our biggest payloads out to GEO, and that never got through the safety process, but they worked it hard. The safety requirements to make sure that the crew was not endangered at any time by anything, either accidental or inadvertent or a mishap, were huge. That's a whole separate discussion in itself, which I'm glad to have with you. But basically, everything was looked at in terms of being dual fault tolerant, so that in no case could any two events link up to cause hazard to the crew, even including a combination of hardware and software errors. This was huge and caused, in many cases, extensive retest and redesign of payload systems. National space policy, back in the 70s and 80s. First of all, in 78, there was a, quote, strong endorsement for the space shuttle to be the prime mover for national security and civil missions. What's missing from this lineup here? Commercial. There were very few, almost no commercial missions at the time. Civil means NASA. So the launch business at that time was dominated by the government, NASA and the DoD. 1982, the position was strengthened. And by the way, I suggest if you haven't already, to look up these documents. National space policy, as voiced in these documents, is extremely powerful. It's a basis for programs, it's a basis for legislation, it's a basis for budgets. It's huge. Every word in these documents is worked over at great length by all the competing stakeholders, and it's big. But in '82, SCS was going to be the primary launch for national security and civil missions. What that really meant was anybody else with a rocket was told, you're on the wrong list. Don't come back. Then we had Challenger, and in 1988, there was now a directive, a 1988 PD, that said we shall have a mix between manned and unmanned launch systems. This is in contradiction to this, I'm sure as you notice. And then NSPD-4 in 1981 now gave us the words, assured access to space. That's code words. Do you folks, anybody here care to tell me what that really means in plain English? Anybody? What this says is, yes?
Even if the space shuttle won't fly, they want to have some alternatives?
That's right. So don't put all your eggs in one basket. Have two ways to get to space for your heavy payloads. This is authorization for what we now know as the EELV, but also at the time, shortly after Challenger, Pete Aldrich, who's Secretary of the Air Force at the time, now an executive of the Aerospace Corporation, previously the director of the NRO, prior to Challenger, in the 84-85 time period, started getting a little bit antsy about access to space because of all the delays in the shuttle launch manifest. And so he authorized, on his own authority, a startup of the Titan fleet again. This led to huge problems with NASA because what they saw that as was, correctly, a loss of support for the space shuttle program. Okay, but he did that, and when the Challenger disaster occurred in '86, the Air Force was about 18 months to 24 months ahead of where they would have been. Here's Dr. Siemens. Hi, Bob.
Hi, Dave.
Sit over here. I'd like to have you meet Dr. Bob Siemens, and he'll be here for the Q&A afterwards. Okay, right. Bob, I'm just going over some of the national space policy write-ups that kind of led to where we are today. This was NSC 37. This was NSC 42, the primary launch. This was the post-Challenger mix between the manned and unmanned systems, and then this was the Assured Access to Space Presidential Declaration. Okay. From a user perspective, the security requirements to fly on shuttle were huge. What was required to be protected was any information on the mission type and details. LEO, GEO, HEO, you name it, that could not leak out. Any information on the spacecraft, who made it, where it was supposed to go, of course what the payload did, had to be protected. Also protected was the program office and the prime contractors, because often you can tell from that who does what. And during operations, the deployment time, location, and the final payload orbit had to be protected. This is huge. As you know, thousands of people participate in getting a mission together for the shuttle. It starts with a mission planning template that's roughly 2 to 3 years prior to flight. It goes all the way through preparation of the flight plans, the mission rules, the launch constraint documents, the processing, and finally the on-orbit ops. All that had to be protected, and that was big. It was a huge and expensive philosophy. It was called the control mode security system. It took a lot of effort from all parts, and it was almost airtight. Yes, question?
Was this for every shuttle mission or just DoD payloads?
No, this is for what I call the intelligence community, DoD missions. Okay. So if you go back and look on the shuttle manifest, what you'll see, and I'm not going to do it for you, but you can do it if you want, you'll see a number of missions where they'll say DoD mission, payload type not unknown, but not available, NA. Also, the DoD/Air Force missions were all military astronauts. That is felt to be a safe thing to do. For implementation, there was encrypted voice data and commanding links, starting really with the testing at the launch sites, but also going through the flight ops. I mentioned all these things. Having been involved in the safety certifications, I'll say that was long and arduous. The safety review process has to be extremely thorough, starting early on. It's not just a whitewash of what the hardware is that comes to the pad. In many cases, it changed the design of the spacecraft, design of its deployment systems, and things like that. To protect classified information, there also had to be need-to-know access to program details. This was a major set of impacts to the Space Shuttle system and payload mission in all these areas, which I can talk to you about at great length afterwards. I will say, though, that when I go down, when I do get back to JSC, or when I talk to my NASA friends, they all say they were proud to have been on those missions. They were all hooked together on missions of great national importance. To the best of my knowledge, security has held tight over all those years, despite all the people who were cleared of the programs, and the programs were extremely successful as a result. Yes?
You said all military crews. Does that mean active military or people who had transitioned to the regular astronaut corps from the military?
These are military folks who transitioned into the astronaut corps.
Okay.
Yes. There are also impacts to the Air Force satellite comm networks. As you know, these are the worldwide set of tracking stations that were going to be replaced by TDRS. And that's an interesting story. The selling point for TDRS was they would shut down the AFSCNs, which were getting old and were very labor intensive. Well, we still have them both today. Worldwide network scattered around the world. But to provide secure shuttle comm, there had to be extensive upgrades, because working with a shuttle with a complicated payload in orbit, getting it initialized, tested, and deployed was something new for the SCN. The SCN ordinarily just did space-to-ground data transfers to orbiting satellites. So to be working with a human crew, a human system, to have all the contingencies in place was big. So the SCNs were involved in all the pre-launch testing and commanding, health and status checks, as well as all the deployment and post-deployment payload comms. I wish I could show you the contingencies, all the workarounds, the plan A's, the plan B's required for a complicated mission. It's immense. It takes a long time to do it right. The point is that when you're ready to fly, you should be ready for all known contingencies, even up to loss of comm, failure of critical computer systems, and this sort of thing. You never want to fly and have to scratch your head and say, what should we do next? Pre-first flight issues in STS-1, another MIT professor, Gene Covert, who's also here, and someone you really should talk to at some point in time, was part of a panel that reviewed the Space Shuttle main engine qual testing, and they were the folks that really came to grips with this new and emerging issue called turbine microcracks. The turbine blades in the SSME were found to be developing very small, cycle-dependent microcracks. The question came up, what's their ultimate failure mode? How many cycles can they stand? How good are they good for? The original intent, as you know, was to be able to refly the SSMEs with zero maintenance between flights many times. That hasn't happened. But even the question of would it be good even for one mission was a big, big question. And Gene, who's an extremely thorough manager and engineer, a lot of common sense, a lot of smarts, worked that very, very hard. There were also issues, of course, about thermal tile loss. There's questions about whether those would fall off. This is not ice now. This is thermal tiles. And at the same time, there were huge costs growing in the development of the IUS, the Shuttle Centaur upper stage, and also the Vandenberg facilities. Everything was either late and or over cost. Many folks thought that the IUS would never fly because its development problems were so huge. The fact that it has flown as many times as it has on a variety of launch platforms is truly amazing from my sight. Then we also saw, prior to first flight, several delays. 2.5 years is about right. And then more delays ensued. And so from a user perspective, all these delays really added up to lost opportunities, extensive cost growth, and things like that. Really a heartbreaking story. This is a picture of a Defense Satellite Program, DSP, machine lifting out of the shuttle bay. I think you've seen this. This is the IUS turntable. It rotates the vehicle up and pushes it out with springs. This is a 2-stage solid in this configuration that takes the beast out to geosync. Okay. Post-Challenger, space policy was changed. The shuttle was not to be used anymore for lifting all satellites, but only for missions where human presence was required. But there was a problem. Because of the backup of missions, the STS had to fly out the existing DoD payloads. We looked very hard at converting them back to the Titans, but since we'd taken steps to kind of shut down the Titan line, the Titans weren't ready at that time. But what we saw afterwards was increased use of a restart, really, of these efforts, modernizations. And that was interesting because there was always a chance the shuttle could come back and launch hopefully 15, 20 times a year, and we hoped it would happen, but it never did. Steve Dorfman from Hughes was here as a visiting professor several years ago. He was extremely bitter about the fact that from a satellite manufacturing point of view, he had to eat the costs to switch back to expendables from a shuttle. So first he was told by National Space Policy, thou shalt fly on Space Shuttle. Then he was told, you are now barred from flying on Space Shuttle. Huge loss to him, and I think Hughes is still contesting it. I don't think we'll never win that in court. And kind of most importantly, from a Central California point of view, the Vandenberg shuttle facilities were shut down completely. So my DoD STS mission involvement personally was, I worked on the very first DoD-sponsored mission, STS-4. It was Columbia, launched in late June of '84, flown by Ken Mattingly and Hank Hartsfield. This was going to be this was a pathfinder for the DoD. It was a test not only of the security procedures, but also the ability to do launch operations, orbital operations in a classified way. It came out extremely successfully. We learned a lot. It was not easy. Getting any complicated mission to fly on the shuttle is a very, very difficult process. To do it under the cloak of security makes it even harder. I was the primary DoD launch integrator, the interface between the program office and the Air Force for 2 primary missions. I shadowed 3 others. I was also a member of the NASA DoD Safety Review Team. This is interesting. The Safety Review Team, or the SRT, was a very small, streamlined, fast-moving team that basically reviewed and bought off in the payload. So as opposed to having the literal or the figurative cast of thousands, we had a cast of just a very small number of people, both from the DoD and the NASA side, and we moved as quickly as we could to get these missions approved and bought off. And lastly, in the mid-90s, I was a program manager for the DoD Space Test Program. STP is in existence today. Their charter is to be the sponsor for space experiments with military relevance. They flew, among other things, the first atomic clocks that led to GPS as we know it today. They continue to fly, numerous secondary and piggyback missions, not just on Shuttle, but also on Arianes, Russian vehicles, Korean vehicles, Indian vehicles. When I was the manager of the program, it was great. It was like you're running a big used car lot and you were offering rides to everybody. It was terrific. And the emphasis here is to use excess launch capacity to fly space experiments, who you'd screen every year, and then on rare occasions you would build a dedicated satellite and launch vehicle about every 4 years to launch the bigger satellites. So my summary is that the DoD had requirements that really went back to the first years, the first days of the shuttle program. They were extremely demanding, and they dramatically affected the architecture of the space shuttle system. The heartbreak, of course, as we know, is that we never were able to achieve the launch rates and the low recurring costs that were promised. That really, when we realized that it was slipping away, those are truly sad days. I don't think anyone ever anticipated the one-time expenses and effort required to redesign payloads, not just for mechanical form, fit, function, but also for safety. No one realized the extensive work required to certify the payloads for manned operations. The mission integration of the Cape was very complicated, and security, as you can tell, permeated everything. And lastly, the sad thing is that MOL and STS at Vandenberg all suffered from the curse of Slick 6, which was that both programs were canceled despite millions of dollars put into refurbishment of the facilities. I have here a list of references. Heppenheimer's book, Development of the Shuttle, I found was quite good. Talks a lot about the programmatics of the space shuttle. I hope you've had a chance to read it. I took some information from here. The Federation of American Scientists, the FAST site is interesting. I think it's still current on the space shuttle. And then there are these books here which I point you to, give you a little bit more insight into the missions, the roles of the intelligence community doing things such as flying and operating satellites in space. Okay. If there's any questions, I'll be glad to take them now, and then I'll show a short 10-minute video. How am I doing on time? I'm moving fastly. Yes, question?
So how many times was the Vandenberg facilities used? Was it even used to launch the shuttle?
Slick 6 never saw anything launch out of there until they launched a Lockheed low-cost machine called the Athena, about 1996. Presently, the Delta IV, remember the big machine that flew out of the Cape about 9 months ago, is stacked there at Slick 6, ready to go with a payload, operational payload. They're having big concerns about fuel slosh, and so their launch date, which was going to be last week, has been rolled off to the right several months. They had a problem on the first flight of basically fuel cavitation, and they're not happy with it yet, so it's ready to go. When the Delta IV launches out of Slick 6, it will be the first large payload system to go out of there ever since it was, well, for the first time, really. Okay? Question? Yes?
I don't know if it's really fair, but in hindsight, was it worth it for the military to get on board with the shuttle from the military's perspective?
Well, if the promises had been kept, it certainly would have been worthwhile.
Yeah, with the way things have turned out.
Was it worth it?
We were kind of driven into it. Can you say, was it worth it from a cost point of view, from a schedule point of view? The answer is no. I think from a perspective of having people do extremely difficult tasks under very pressing circumstances, it showed us what NASA and the Air Force could do, although at great cost. It was certainly one of the more, I won't say exciting times, but it was. It was one of the more exciting times for NASA. Okay. Questions? Yes.
When you talked about safety certifying these payloads, was it mainly an issue of the fuel supplies for the payloads?
Well, I'll just give you one example. To get a payload into the bay and to withstand launch loads, you have to have very large structural members, steel rods, for example, that had to take all the launch loads and not have the satellite break away inside the payload bay in the worst case, either during liftoff or in the worst case on landing. So you could have as many as 18 to 24 steel bolts, all had to be fractured simultaneously within seconds by pyrotechnics to get them out. You had to prove by analysis and by tests you could have all these simultaneous events for which you could not have any redundancy. You just couldn't do it. These were must-work devices. As probably Professor Hoffman has told you, on every shuttle launch, there's a large number of must-work Category 1 issues and items, like the bolts that free the external tank from the vehicle. If those don't work, you got a big problem. Okay. So from a safety certification point of view on the shuttle, we had to make sure that in no case could the payloads pose any hazard to the crew under any circumstances, including the ones that were the most far-fetched, such as landing overseas in Spain or Morocco. Okay, but the things we worried about was having a payload hung up during deployment so the shuttle couldn't return, or a payload damaging the shuttle at any time and causing, obviously big problems there, and things like that. Plus things such as propulsion systems accidentally activating. Liquids, solids, didn't matter. All extremely hazardous. And we found out a lot, because it's one thing to design a payload for launch and expendable. There are certain things you can or should not do, but when you go to a shuttle context where you have a lot of commanding going into the vehicle, pre-flight, during ascent, in ops, it becomes a much more tough problem. Well, for example, I'll just give you one example. If you have a very complicated payload, which consists of a spacecraft bus, all the housekeeping, and the payload front end, which may have all kinds of hazards associated with it, like antenna booms that come out on command, how do you verify final configuration before you lift off? How do you know every circuit, every system is in the state that you think it is? How to verify that? That is very hard. Okay, because you can go in there with test equipment, but test equipment has subtleties all its own. Okay? Good questions.
Do you think it would be possible to do the one orbit and return to base type mission? It sounds very, very difficult to do.
It's not that hard. First orbit deploys were not easy, but they were done. Coming back, I think the big problem is that it really forces the timelines, because as you know, to do a deorbit burn and return to Earth requires quite a bit of mission planning, real-time updates to verify you're on the right track, plus making sure that you have everything right, so when you do the deboost, you're going to be within your corridors. To the best of my knowledge, NASA has never done a first orbit return, and I don't think they'd want to. It's very, very stressing, because in 90 minutes, you have to not only get the spacecraft out, but then the vehicle resafed and buttoned up and planned out to land back either at the primary or an alternate landing site. So that's a lot of work to do in 90 minutes. Okay. Any other questions? Yes.
Is there any way to give a ballpark figure of how many DoD payloads were put into space by the shuttle? Is it tens or hundreds?
Oh no, it's not hundreds. Jeez, it's you can look. You know, the NASA manifest is published from the what they call the regular Air Force side. They launched a whole series of comm satellites, Discus, DSP. In fact, the very last DSP satellites are still shuttle compatible and could be launched if there was a problem with the Titans. So they're up there in storage up in Southern California. And then there were a fairly large number of what I call intelligence community missions that were flown. And all the manifests will say all it will say is that these were just DoD missions. Okay? Let's see. What I'd like to do is ask Tom to shut off the videotape, and I'll give you a little introduction to my video, which I hope will run. Bob is really we're ready to start here, folks? Bob Siemens is really a very pivotal person, not only in the space shuttle story, but also in the Apollo program, which he can probably talk to you at a separate time, but I think he'll like to spend 10 or 15 minutes talking about his role in the space shuttle story.
Okay, here we go. Just wondering where to go to get comfortable. And can we turn that? We can't turn that off.
You can hang down that side.
I just like to get comfortable here. Yeah, as Pete said, first of all, I thought that was a great summary of actually a very difficult subject to discuss. Let me just take you back first of all to the early '60s. I know that's going awful far back, but that's when I joined NASA as a general manager. And before we knew it, we'd gone from a $1 billion a year operation with the Mercury program to the situation where we were given the assignment of putting men on the moon. And that was a gigantic shift in our responsibility. And in all of the planning and the discussions and so on, we wanted and we did work very closely with the Department of Defense. The Department of Defense had all kinds of assets that were going to be required in the space program. The Navy, for example, to pick up the astronauts, and was one example. A major example most people never heard of, and that is we had to construct very large facilities, of which the most famous and obvious was the vertical assembly building and the launch facility down at the Cape. You just saw the shuttle taking off from that facility. And in operating down there at the Cape, there already was Cape Canaveral, and there wasn't room for what we were going to do to fit on Cape Canaveral. We looked at 7 different world sites and finally decided to camp on Merritt Island, which is just across the river from Cape Canaveral. Because, again, the Department of Defense had all kinds of facilities down there with a tracking range and so on. But the biggest support that we got was in the building of those facilities. It was absolutely no competence in NASA to build the largest structure in the world, the VAB, or many other facilities for assembly and for test and so on. So the Corps of Engineers was a major part of the operation. I'm bringing this out because we had to figure out how far we're going to go with our launch vehicles on a shared basis. This is before anybody thought of a manned shuttle that would carry stuff up and stick it into orbit. But we put together a planning organization. It actually operated for over a year's time. A fellow named Golovin for NASA, a fellow named Kavanaugh for the Department of Defense put this together. One of the big emphasis was the use of the Titan. The Titan was coming along to the point where we thought the earliest version would be suitable for the Mercury program, and at that time in 1961 we were thinking that Mercury only weighed 3,000 pounds. You could put one man in it. You couldn't do much with it, but if we could in effect just enlarge it and have a more powerful vehicle than Atlas, namely the Titan, we could really have a vehicle that would have some capability to run through a lot of the orbital operation and so on that were going to ultimately be required for going to the moon. And out of that came the planning for the Titan III, the Titan IV, and vehicles that proved right off the bat and over time and still are very, very important to our defense capability, as well as well, I don't think that's quite true. I don't think we are using any of those assets today within NASA. And if you then go forward in time, in 1968, I'd been down there in NASA for 7.5 years. I planned to go down for 2. I came back. MIT was nice enough to invite me back, and I came back right here as a Hunsaker professor. To my very great amazement, I got a call one day from somebody I'd never met, namely Mel Laird. I just barely knew that he had been designated by Nixon to be the next Secretary of Defense. He said, "You're going to be down here in Washington the next day or 2, and as a matter of fact, I was, because I was going to go down the next day to get on a plane and fly down and see the launch of Apollo 8, which was going to fly around the moon. And he said, "Well, come on for lunch." So that's when he asked if I'd be willing to be the Secretary of the Air Force. I told him that's absolutely impossible. We just moved our family back here. My wife's in the hospital, which she was. But he was very persistent, and after about 10 days, I agreed to go back down in the government. And but that's a long story you don't want to hear. The details of getting my wife well and getting a house and all that stuff. Now, one thing that I inherited right off the bat was a manned orbital laboratory, and even then, it was clearly in some jeopardy. When programs start getting a ceiling built in, where they say, "Yeah, we're going to keep it going, but it's going to be kept going at a level of," and I forget what the level was for MOL, something like 500 million or something like that, because any large program over time, there's always opposition to it, and there's more time for it to be shot down and ultimately eliminated. I realized that it was in deep trouble when I was over in the Bureau of the Budget talking to a junior member of the Bureau of the Budget, and he said, "I hope you realize that the shuttle's in deep trouble from a standpoint of support here in the White House." And so I went back to Mel Laird, and I said, "Look, one thing I want to do is to have one shot with the president to see if be sure he fully understands what the capability MOL will be." It was far along. Lots of expense had gone into it, including major facility construction out of Vandenberg. And so I had my day in court. It was a sunny afternoon. I got General Stewart, who was very involved in the MOL, to join me, and Mel Laird, and we went over there. It was just Kissinger and the president. I had a few simple-minded charts that showed what we were going to do from a resolution standpoint if we kept going with the MOL, and what that would mean in terms of understanding more clearly what was going on in a given situation. I had my half hour in court. I could see a band outside getting ready to play, so I knew that the president was about to be rushed out for some kind of a ceremony. That was a Saturday. Monday morning, I got a call from Kissinger, and he said, "Bob," and I can't really imitate his German accent, "that was a very, very fine presentation." And a day later, I found out that the MOL was canceled. That was with President Nixon. He sat there the whole time. He had a yellow fool's cap. He took prodigious notes of everything I was saying, which was sort of nerve-wracking. The President of the United States bothering what I'm saying. But anyway, that's sort of where I came from from the MOL. Now, the next step along the way was after Apollo, what was going to happen in space. The were to be 8 launches of the Apollo lunar program. Nixon cut that back to 2, sort of arbitrarily, and there were no plans for using those assets. Jim Webb was my boss in NASA, and I used to see him. He was very ill the latter part of his life, and I'd drop by and he'd ask me strange questions like, what do you plan to do with your life before you kick the bucket? Kind of questions like that, and he said, I haven't got long to live, and I say, you're doing fine, Jim, and I'm just going to work along, see what I can do to help out here and there. But anyway, his big thrust was, we felt we were building a major capability for the country, and now it's all being washed away. And what's going to replace it? The shuttle came up as an option. It actually, you say on the surface, makes an awful lot of sense to recover something. We could easily visualize a transportation system for the country where every time a 747 went across the country with a payload, everybody jumped out and then you threw it in the ocean. It didn't seem to make much sense. You just knew it had to be more efficient to reuse something. Although, with Gemini, we had looked into that possibility. We were recovering the Geminis. Why didn't we use them again? And we found we're going to have to put probably 75% of the original cost into reactivating the Gemini. So actually, I had a hunch that it wasn't going to be quite as simple as landing an airplane and then taking off again. The Air Force was going to be one of the prime users of the shuttle, and the question was, how large did how large did how large did the experimental bay have to be for the missions that were going to be carried out? There was no thought, let me just quickly say, of putting armament aboard the shuttle. I misspoke. And then the question was how rapidly. One of the questions was, did you have to recover it if something happened and you wanted to bring something back in a hurry? And to bring it back, you had to get you had to make a coplanar change, and that was going to take a certain amount of energy, to put it mildly. And so anyway, those are many of the issues, and I think, as I remember it, my friends in NASA thought the Air Force was being pretty tough on them. But if we were going to accept the use of a vehicle, in all seriousness, as you've just heard, it had to have ability to carry out the missions, and so that was sort of the next step along the way. And then, after I got through in the government, I ended up some years later out at Aerospace, and ended up as the chairman of the corporation. And they worked closely with that element in the Air Force that was so much involved in these type programs that you've just been hearing about. And we were beginning to go into shock, at least those in the nucleus who were sort of running the aerospace, Eberhard Rechten and myself, that more and more it appeared that we were going to not be allowed to put anything in space except through the shuttle. And that seemed to be eminently wrong, to think that you're going to have to risk the life of astronauts every time you want to put any kind of a satellite in orbit. From the standpoint of a paperclip individual who's looking at cost, to just have the one vehicle and use it and use it and use it, and thereby supposedly cutting the costs, had a lot of charm. And it reached the point where he and I decided we had to try to do something about it, and we made an appointment with the then Secretary of the Air Force and said, you've just got to be stashing away Titans somewhere, so that if we run into trouble with the shuttle, we're going to be able to move over and put these very important payloads into orbit. And then they had the Challenger accident, and at that point, this, I think, major fallacy in policy was changed back where it should have been. You just shouldn't rely on a single vehicle. And that's my introduction, yes.
You wanted reusability, but some people also didn't want to risk the lives of astronauts. Why not make a reusable unmanned vehicle?
Okay, that's a very good question, and why couldn't we do it? It might be a good design challenge for you guys here in this class to investigate that possibility.
I'm unmanned. Yes.
We've gone part way in that direction by recovering the shuttle casings, obviously the shuttle itself, but trying to recover at least elements of the unmanned launch vehicles, and I'm not prepared to really give you a definitive answer on that.
That's a good question. We'll talk about it later.
Yes.
Before the shuttle concept was finalized and the military requirements were finalized for the shuttle, the military had been launching their satellites and their missions using the Titans and the Atlases, correct? So why did this requirement of the shuttle having to be able to bring back a satellite, presumably a military satellite, when that wasn't being done or required beforehand? Like, why was that created? What was so special about it?
We worked very hard on proposals to bring back satellites that were out of fuel or needed refurbishment. But when I was referring to landing with a shuttle with payloads in the bay, that was for a failed mission. If for some reason the payload could not get ejected, you still had to be able to land back with this now a very heavy spacecraft and glide on in and land safely. That turns out to be a really hard thing to do, especially if you're carrying solids and liquids on board that were close to being ready to ignite, so to speak. So no, but there was talk of retrieving satellites, and as you know, NASA did bring back some satellites, small ones, the Palapa one from Hughes, and also did a lot of very innovative repairs in space. But when we looked at it from a customer point of view, it turns out there's a lot that wears out in satellites, not just using a propellant, but processors degrade due to radiation, solar panels degrade just due to microdust and things like that. And so bringing back a satellite for reuse was never felt, at the time we looked at it, to be a worthwhile thing to do.
And that ties in directly with what I was saying about recovering a Gemini. And of course, on top of that, with the Gemini, the fact you're landing them in the water, so they got a good dousing of salt, and so the degradation of the Geminis was such that we just didn't think it made any sense to try to refurbish them. Yeah.
So the military was only really looking to capture and service in space, then release, not necessarily capture and bring it back?
They never seriously went after the capture and refurbish or release. They really went after really launch and deployment. But I'd say that in that theme, the most successful stories actually of refurbishment is the Hubble Space Telescope, and not for the reasons that you think of. When you hear about stories about the Hubble Space Telescope, you hear about Jeff Hoffman going up there and changing processors and fixing the optics. Also in those missions, they replaced solar panels that were causing huge problems due to thermal warpage and shrinkage and what they call oil canning due to thermal stresses. And so the replacements of those solar panels, which turned out to be not very good when it as initially designed, is one of the really true success stories of man in space. And there's actually a very nice video, which maybe you've seen, I hope maybe you have, of the lady astronaut who did the replacement of the solar panels on Hubble, pushing out and releasing the solar panels, and the things fly away in the sunshine, looking like giant butterfly wings, reflecting all the colors, and then finally fall into the atmosphere. It's almost poetic, I tell you. It's amazing.
On the Hubble, one of the considerations right from the beginning was that it should be a serviceable satellite. It was designed so that you could get inside of it relatively easily and so on. And frankly, I don't know of any other satellite that was really designed quite that way. Maybe I'm wrong.
I believe you're right.
But on the solar panel, it wasn't designed to have to replace the panel. But you can go back to Skylab, which was the next to the last launching of the Apollo. And on that one, I guess, you know, we decided to take what was the third stage of the Saturn and just gut it, not have any propulsion in it, and fit it out to be a spacecraft, namely a space station. And when I got up there, the solar panels got fouled up, and one of the real tricks when the astronauts first got to it, because it was not launch manned, was to unravel some wires that got caught on it, and so that they could actually, so the panels could spread out and it could start to operate again. Yeah.
Cornell or Siemens, I don't know if either of you would know, but what is the DoD's involvement like for the heavy payload aspect of the new CEV project?
Well, the Delta IV going out of Vandenberg is carrying classified payload. It's not a dummy either, so it's real. So they have standing requirements for these types of things. You know, the national needs go on. The international stage, as we know, is filled with new actors, new threats. We have what's called unsymmetrical warfare, things that are hard to counter by conventional means. Back in the 70s and 80s, we had symmetrical warfare, you know, submarines versus submarines, missiles versus missiles. Now, as we know, it's much harder, much tougher, but the needs are still there.
What is the collaboration between NASA and the military still pretty active?
It's not in terms of payloads, it's their exchange of technologies. Things like development of more efficient sensors, processors, that sort of thing. It's everybody's benefit, for example, to have more powerful, faster, rad-hard space processors. Everybody wins in that type of situation. Okay. Back to your question on reusability, you'll notice that one of the real strong pluses of the calling cards of the Space Shuttle program was the fact that it was a reusable launch vehicle. In this current environment of CEVs and new launch vehicles, what do you hear today about reusable launch vehicles? Nothing. Isn't it amazing how things have changed just in a matter of 20, 25 years?
Yeah. One thing I just sort of forgot to mention with regard to the Manned Orbital Laboratory, it was thought at that time that by having men there and their ability to inspect a fairly wide swath, that they would have time in flying over that swath to do some searching and could do a better job of detecting possible items of tremendous interest from a military standpoint than trying to do it all automatically. And of course, what finally washed out that argument was the ability to have satellites that had almost instantaneous transmission of information back home.
What was the design for the MOL
For crew transportation.
They were going to take off on a Titan. They were going to be aboard a Gemini, and they were going to have a laboratory of sorts, which would have the necessary reconnaissance and other equipment aboard.
So it was similar to Skylab in that you had a non-reusable capsule as the crew transfer.
It had a Gemini type return vehicle, but it was definitely going to be quite small and cramped compared to Shuttle.
There was no thought of having another Gemini come up and make use of it. Yeah.
Why did Gemini, Apollo, Mercury all land on water? Because that's very expensive, and the Russians landed on land.
Well, it's very simple. If you take a look at where the launch sites were for the Soviets, if they aborted, they had to come down. They had to have the capability of coming down on land for any kind of an abort mission. Similarly, if operating out of the Cape Canaveral area, if you abort, you have to come down in the water. Now the question was then, was it worthwhile to have the capability of doing both? Well, that just added weight, and so we stuck with the water and they stuck with the land. Yeah.
Do any of the new defense payloads require human intervention in their deployment, or are they all completely autonomous?
They're all Titan 4 EELV compatible. Yeah. Anything else?
I think we won everybody out.
Well, Bob and I will stick around, but we're not going to hold you down here if there's no questions. So I guess we'll call the class, and we'll stick around if anybody wants to ask any more detailed questions or have follow-ups. My phone number and email is up there. I'll be glad to talk to any of you one-on-one about any of this. There's quite a lot more detail we can provide, either Bob or myself, and if I have to, I'll write Bob a note asking for further information. Okay? Well, thanks a lot.